Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 4, Lesson 2, on Important Concepts to Know by Unit 4. So, if you thought that Algebra 1, if you thought that Algebra 2 was easy, think again, maybe, because this is the point where people start to think that it's kind of hard. Maybe you thought that in Unit 3, but you definitely will think that in Unit 4, even though maybe it seemed easy to you about classifying polynomials that we did in Lesson 1. But there are 6 different concepts that are crucial to know before I go any further, because in the next lesson we will factor polynomials, which is very crazy and kind of hard. So these 6 concepts, some of them you've been learning even since elementary school, but maybe you never fully grasped the concept. Well, that's important that you do that. So here are the 6 ones. And as you can see, I'm not on the usual thing, just like on the last lesson, because that app was so stupid that I had to delete it, and that's kind of unfortunate because I've been using it since, I don't even know, November or something, and messed up. I don't even know what's wrong with it. It was just like a black screen, but whatever, or a white screen. It just had nothing on it and it wouldn't let me draw. This thing seems like it's kind of the same thing, so I'll just use this from now on unless the other thing fixes. So here's the first thing. The first thing is concept of signs. So this is the first thing. Okay, kind of big. So, okay, this isn't as good, but whatever. Can I change the size? Okay, maybe this will be better. Alright. Okay, so signs. You need to know, this basically just means when you're multiplying and dividing with certain signs, you need to know the outcome. So in case you didn't know, if you multiply a positive number times another positive number, you will get positive. And if you do a positive number times a negative number, you get a negative number. Same thing if you do negative times positive, you get negative. But if you get a negative times a negative, you get a positive. So hopefully you know that, but you might not if you didn't understand that. And the same thing goes for dividing also. So I'll just do this. So you see, if you multiply or divide, if the signs are the same, positive. If they're different, negative. So that's the first concept. As you can see, this kind of looks like the same sort of, the same kind of thing a little bit, but there's some other options down here that I haven't seen before that aren't on the other one. The eraser is not as good. So that was the first thing. That's not really that complicated. You probably should know that, but I just thought I would say it. So concept of square roots. This is something that you might have not learned until Algebra 1, but since these videos are designed for people in Algebra 2, then you should know this, I'm pretty sure. But it's okay if you don't, but you just need to make sure you know it from now on, because when you go into the next thing, they just assume that you know that, and there's not going to be any explaining. Although I will, but your teacher might not. So if you you need to know the concept of a square root. So if you have a square root of 4, you might have used to just said, 2, because you know that 2 squared equals 4, so you think, you do reverse psychology, and you know, square root of it must be 2. Well, here's the thing that's a little bit tricky. So you may know that these are opposite properties, or opposite, what would you call it? Just they're opposite things that you can use. Like opposite, I don't know why the word just left my mind, but you know what I'm talking about. They're opposites of each other. So are multiplication and division, and to an extent, squaring and square rooting are as well. And now that you know that distributive property is kind of the opposite of factoring, too. So that's kind of how it is, but the difference is that when you take a square root of a number, you get two answers. Not just plus 2, positive 2, you also get negative 2. So that equals both of those things. That's what plus or minus means. So hopefully you know that, but if you think about it, we already talked about that in the last unit. Because remember, when you have a quadratic, the solutions are where it touches the x-axis, and there's 2, unless it happened to be like this, where it just touches at one spot, or if it happened to be up here. And remember, that would be if it's imaginary. But if you have a negative number squared, it's always positive. So even though the square root of 4 equals negative 2, negative 2 squared, well, I mean, what am I saying? Negative 2 squared is 4. And it's not negative 4 because nothing squared equals a negative number. We already learned that. And if you have a negative under there, that's not something that there is. But that's the 6th thing, but we're only on the 2nd one, so we're not doing that yet. Also, you need to understand the concept of radicals. Hang on, is this thing seriously not going to... Maybe object eraser would be better. Oh, yeah, that's better. Okay, so radicals. So we know that there's perfect squares, so let's take 64, for example. We know square root of 64 is positive and negative 8. We just talked about that. But sometimes you're asked to take a square root of a number that is not it's not a perfect square, like 63. And of course, you could just consider that simplified, but you can simplify radicals. And I already talked about this in the last unit, but just to review, when you are breaking down radicals, you think of two numbers that can multiply to equal the number under there. So what two numbers equal 63? But one of them has to be something that is a square that you can take the square root of, like 64. So off the top of my head, I know that 7 times 9 equals 63. And this is a good example because 9 can... You could have done a one like 21 times 3, but that wouldn't be useful because you can't take the square root of 21 or 3 and get a whole number. But you can for 9. So you take the square root of 9 and then you get 3, but you can't take... We don't want to take the square root of 7 because it wouldn't be a whole number, so we'll just put it beside it. 3 root 7. So that's breaking down radicals. That's something important to know, because you'll have to do that in the next lesson. All these things you'll have to do next lesson. So that was the second thing of the 6th. The third thing, you need to understand the concept of factoring. I told you in the last unit that there was 3 ways to find the zeros or x-intercepts of a quadratic. You could complete the square, you could use the quadratic formula, or you could factor. And I told you that I like the quadratic formula the most because it always works. Well, in factoring polynomials, we know that polynomials can be quadratics from the last lesson, but they can also be cubic functions, and in some cases, you won't be able to use the quadratic formula, and you'll have to factor. And not only that, you'll need to know how to factor for other math classes like pre-cal or any other math class you might take after this. Factoring is a very important skill, and I didn't mean to not make that clear in the last unit. So sorry if I try to make you think that it was just something random that you don't have to learn. It's important. And remember, we learned different ways to do it. So remember, we had one like this. 2x squared plus 4x. where there's one where you can divide. You divide, it's basically the opposite of distributive property. You divide by a certain thing that both can divide by. Well, we look at the coefficients, 2 and 4. They can both divide by 2. And basically we're saying just so we can get whole numbers. And they both can divide by x, not x squared, because this is an x squared. So then you take the 2x to the side, and then these will cancel out, these will too, but there's still an x here, so x, and then 4 divided by 2 is 2, and then the x's cancel, so that is how you factor that. And when you're trying to find a 0, you would always set it equal to 0, because remember, zeros mean x-intercepts, and whenever there's an x-intercept, the y value is 0. Anything on the other side of the equal sign is what the y is. So that's why I set equal to 0. And then you would do 2x equals 0, and x plus 2 equals 0. And then you would find that x equals 0, and x equals negative 2. So this would be a quadratic, remember, quadratic binomial. And that means that it would, since it's positive, we know it points up. A review from last unit, and it would look something like this. So there you go. That's factoring. Remember, there's other ways to factor, but you need to look at the last unit videos to see that. But the one I just did is what you use the most. Well, you still use the one where you. Let's just look at that real quick. So let's say we had this. This is another one that you use a lot. So you remember, this is the bottoms up factoring one, where you have to take the 2 and you multiply it by the term with no x, or the constant. So then you have x squared plus 3x equals 8, or sorry, plus 8, not equals 8. And then remember, you need to see if there's any two things that multiplied equal to 8 that can subtract to be 3, and let's just pretend this was a 6, because that just for this purpose. So 4 and 2, they multiply to equal 8, and they add to equal positive 6. So then we know that it's this. And therefore, if we set this equal to 0 to find the zeros, we know that x would equal negative 4 and negative 2. And since this is positive, we know it would point up, so it would look something like this. So there you go. That is factoring. That's the third thing you need to know. So that was a required standard anyways for the last unit, so I would hope you know how to do that. Number 4 is the quadratic formula. So although I told you that you usually will factor for polynomials, you'll still have to use the quadratic formula, and we'll see why in the next lesson. But you know how there's only one x-intercept for a linear line that you learned in Algebra 1, but there's 2 for quadratic, and there even can be 3 if it's a cubic function, or 4 if it's a quartic function that we'll learn in the next lesson. So when sometimes factoring doesn't always work. Like, remember that I changed the 3 to a 6 because that wouldn't have worked for factoring. So quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac divided by 2a. You should have this memorized because it's very useful. And I already told you before that I have it memorized because that's what I had to have memorized. Okay, so I actually have to go kind of fast. So remember, I don't need to tell you what A, B, and C are because that's in the last unit, so you should know that. I have a thing to go to in less than 30 minutes, so I kind of have to wrap this up. So the 5th thing is the concept of solutions. So I kind of already said that. So what are the solutions? When you're asked to find the solutions of a certain polynomial, so remember, quadratics and linear lines are considered polynomials. So even though you just learned what it was, maybe what the name meant, you already have been dealing with them. So if you're looking for the solution, it just means where the x-intercept is. And here's other names for it. So there's solutions, let's say sols, zeros, they're called zeros sometimes. well, I don't know if you would really say, I guess you might say that, I don't know. You most commonly call them x-intercepts, and you also call them roots sometimes. They all mean the same thing, so you need to understand that, because you need to understand that. And to find those, you need to factor or use quadratic formula, as long as it's in standard form. And I kind of forgot to mention this on the last video, but standard form just means where the exponents are arranged in highest to lowest order. So if it was quintic function with a 5, you need to have the 5, 4, 3, 2, 1, whatever order they're in. They just need to be from largest to smallest. And the last thing, the sixth, is you need to understand situations that can be imaginary or non-real. They don't necessarily mean the same thing. If you take the square root of a negative number, like -1, you get an imaginary number. And you need to simplify that. We already learned that in the last unit. If you have 0 on the denominator of an equation, that's not a real number. Non-real, because you can't divide something by 0. So non-real. And then you also can't have something that is or you can't take the square root of a fraction like that, for example, because the denominator also, you can't take the square root of that, so you have to convert that to something else. And so let's look at how we would do this. So it's simple with the thing divided by 0, but let's look at what imaginary can be. So this goes back to simplifying radicals. So let's say we had -27. You take the square root of that. Well, you can't do that because it's imaginary. So you at least, if you take out an I, now it's this. I root 27, because remember, I equals square root of -1. So if you take that away, then now it's, okay, that's better. But that's not it. You need to simplify this. We know that 9 and 3 can multiply to equal 27, and 9 you can take the square root of. Square root of 9 is 3, so you have 3I root 3 as what that simplifies to. So that's what that is. Now when you have, when you take the square root of a fraction, because you'll have to do that sometimes. Let's say we have the square root of 519 divided by 173. What would we do? Now, you might be thinking, oh, what the heck, that's terrible, absolutely terrible numbers. Well, here is actually what you have to do. Since the denominator, you can't take the square root of it, you have to multiply the numerator and denominator by whatever the denominator is, so that it will turn into something that is a square. So now we have 519 times 173, which is 89787, so 89,787. And 173 times 173 is 29,929. So this is now what we have. But that is not simplified, because if you divide 89,787 divided by 29,929, you get 3. So if that's true, that means that you can divide it. This wasn't the best example, but basically, if that equals 3, this thing doesn't equal 3, but we at least know that the square root of 89787 is not a perfect square. You get like 299.6447, whatever. So what you actually have to do is, you should have simplified this in the first place, because 519 divided by 173 can simplify to 3 over 1. So that means you would multiply, well, that already is 1, so you have this as your answer. So this is the same thing as that. So that might not have been a very good example, but that's what it is. So hopefully this video helps and clears up some things, because that's what you'll have to do sometimes. So hopefully this made sense, and I'll see you on the next lesson.